So we have to stop at phi 3 of t, right?
Yeah, pi 3 of t. Yes, I'm asking. Everybody has got the answers. I shared the answers.
Yes, sir.
Okay. Okay, then let me take the next one.
Sir, how to draw constellation diagram when we have three orthonormal basis functions, sir?
Yeah, pi 1 of t. Actually, on text you can write 2D only, no? 2D diagram, right? Means you can write pi 1, pi 2, and pi 3. X, Y, Z we write, no? So that should be the 3D diagram,
Okay, sir.
right? You know now how to draw X, Y,
Yes,
Z,
sir.
right?
Yes.
Same way. Pi 1, pi 2, pi 3 can draw. Okay, so let me take up the next one. Yeah, till it gets on my whiteboard, let me dictate. I think you can all of you can note down this. Using Gram-Schmidth orthogonalization procedure, please have a note of this. Using Gram-Schmidth orthogonalization procedure, find a set of orthonormal basis functions. Find a set of orthonormal basis functions to represent four signals S1 of t, S2 of t, S3 of t, and S4 of t, as shown in figure below. Okay, I will draw the diagram. I will write those signals. Then you can start doing this. Yes, hope you are able to see the whiteboard now.
Yes, sir.
Yeah, I think it is taking time. Just let me. Yeah, first signal. I think let it. I hope we will be able to visualize. You will draw S1 of t. Okay. So x-axis is time, right? Y-axis is amplitude. So interval is 0 to 1. Okay, 0 to 1. So it exists for 0 to 1 with a magnitude of 2. Hope that is clear. S1 of t exists over the interval 0 to 1 with a magnitude of or with an amplitude of 2 volts. You can write a square pulse having duration 0 to 1 seconds with a magnitude of 2 volts. That is S1 of t. Okay. Then S2 of t is from 0 to 2 seconds. Okay, with a magnitude of 2 volts. S2 of t is also a square pulse which exists for an interval of 0 to 2 seconds with a magnitude of 2 volts. Then S3 of t, okay, it exists from interval 1 to 3 seconds, 1 to 3, with a magnitude of 1 volt. Okay, with a magnitude of 1 volt.
So we can't
Then,
see what you're writing, sir.
yeah, I'm not, still it is opening whiteboard. I think, I don't know what happened. Today it is taking time. Yes, it is now opened.
Yes, sir.
Yeah, I think I will open a new file because it is big. I think that's why it is taking time. Sorry. Just I'm dictating. I thought you will be able to
Yes, sir.
write by yourself. I said
So
S1
what's
of
the
t.
fourth signal, sir?
Yeah, force signal exists from 0 to 3 seconds with a magnitude of 1 volt. With a magnitude of 1 volt. ಇಲ್ಲಿ ಬರುತ್ತಾ ನೀವು?
Sir, what is the interval of first signal, sir?
First signal is from 0 to 1 seconds. 0 to 1 with an amplitude of 2 volts. Okay. S2 of t interval is 0 to 2 seconds with a magnitude of 2 volts. Yeah, I think. I can't. Yeah, I think now I got it. So let me write. Hmm? Yeah. So this is my, I think, third example, right? If I'm correct, or fourth. I think it is fourth one, right? Yeah. So the first signal, what I said, it exists from this is S1 of t, okay, 0 to 1. So with an amplitude of 2 volts, I said. And then S2 of t exists over interval 0 to 2 with a magnitude of 2. Then another signal, that is S3 of t, hope you are able to see now. Okay, this is from 1 to 3, having a square pulse with a magnitude of 1 volt. Okay. Then another signal, that is S4 of t. I said it exists over the interval 0 to 3 with a magnitude of 1 volt. Okay. So two signals are having an amplitude of 2 volts. First signal exists over interval 0 to 1. Second one 0 to 2. Third one 1 to 3 with a magnitude of 1 volt. And fourth one is 0 to 3 seconds with an amplitude of 1 volt. Yeah. So you need to find out the set of orthonormal basis functions. Yeah, is there any dependency? No, all four signals are, I feel it is linearly independent, or can I say, am I able to obtain one signal from another signal just observing at this one? Is it possible to say?
Sir, can we divide S1 of t by 2, sir? If we can do that, then we can, sir.
Yeah, we can do that.
Then S1 of t by 2 plus S3 of t. It will give
Yeah.
us S4 of t, sir.
Very good, very good. So it's a good observation, right? So I can say, looking at the signals, I can say S4 of t, S4 of t will be equal to 1 by 2, right? S1 of t plus S3 of t. So I can obtain S4 of t by doing so, by dividing the S1 of t amplitude by 2 so that it becomes 1. Then by adding S1 of t and S3 of t, I will be able to get S4 of t. So which exists from 0 to 3, right? Okay. So with this understanding, now we can say the number of orthonormal basis functions will be less than 4. Okay. Yeah, as a first step, what we need to do, we need to find, yes, Chandrika, can you say Chandrika Murthy? Chandrika Murthy,
Yes, sir. Yes, sir.
yeah, can you tell what is the first step I have to do? How do we go about this?
So you have to find
Ah,
S4, sir.
no, ma. See, I said we observed the signals and we came to know that we can obtain S4 of t by dividing S1 of t by 2 and adding it to S3 of t. So I can get S4 of t, right? After knowing that, I said the number of orthonormal basis functions will be less than 4, I said, because S4 of t is dependent on S1 of t and S3 of t, right? After that, as a first step, what we need to do, I said.
I'm not sure, sir.
You're not sure, means you are not followed so far whatever I said. Chandrika, I said now first step is what? We need to find pi 1 of t, right? So to do that, we need to find the energy of signal S1 of t. So that is the first step. Okay, you have to find energy of signal S1 of t. At least can you tell what is the formula for finding energy of the signal S1 of t? Yes, Chandrika Murthy. Yes, Chandrika, are you there? Energy of a signal. Yes, what happened? You're not responding. Are you there? Yes, you are there very much. Chandrika. Not ready to speak. Okay, what about Manasa?
Yes, sir.
Manasas are there. One Manasa RA or Manasa SH, anyone can respond.
Manasa SH, sir.
Yeah, please, ma.
SH, sir.
Yeah, very good. Yeah. Tell me.
Sir,
Ah. Yes, I am unable to hear your voice. I think some network issue. Okay. E1 is equal to integral
0
0
to
to
t,
t. Yeah,
S1 of
S1 square
S1
of
of S1
t
square of t into dt.
dt. So S1 of t exists for what interval? 0 to 1, right? So that is why I can write limits as 0 to 1, and the value of S1 of t is 2, right? So I can write 2 squared into dt. So which is nothing but 4, right? So it is 4 joules, we can say, for the interval t is 0 to 1. Okay. So after finding the energy of the signal S1 of t, then I said S11 right? S11 will be root of E1, so which is equal to root of 4, so which is nothing but 2. So I can say the value of S11 is 2. Okay. Then after finding S11, I can say what is the value of pi 1 of t. Yes, any one of you can say what is the expression for pi 1 of t? Danya. Yes, Danya.
Yes,
Yeah.
sir.
What is the expression for? Yeah.
5 is equal to S1 of
Uh,
t by root of E1.
yeah. S1 of t by root of E1. Right. So the value of S1 of t is 2.
2.
Right. And square root of 4 I can write. So which is nothing but 2 by 2
1.
only. Right. So which is equal to, can say 1 over what interval? 0 to
0 to
1.
1.
Yeah. And it will be 0 elsewhere. Okay. So the value of pi 1 of t we found. Okay. So the first step is done. In first step, we are going to find out the value of pi 1 of t. Right. In the same way, the step 2. Yes, in step 2, what we find? We write the expression for g2 of t, right? So g2 of t is equal to, yes, Subiksha is there. Subiksha. No, Subiksha. What about Manusri?
Yes, sir.
Manusri is also not there. Yeah, can you tell me what is the expression we
Sir,
can
I'm
write for
there.
g2 of t? Yeah, g2
Sir,
of t.
S2 of t
Yeah, s2 of t.
minus S21 of
Uh,
phi 1 of t.
yeah, s21 into pi 1 of t.
Phi 1 of t.
Okay. Yeah, fine. So now we need to find out S21, right? So what is the expression for S21? Yes, other people should respond. It's Neeraj.
Yes,
Neeraj.
sir.
Yeah,
So
can you tell what is the,
S21 is integral 0 to t, S2 of t, phi 1 of t dt.
yeah, S21 will be equal to integral 0 to
0 to t.
t, yeah, S2 of
T.
t into
Phi 1 of t dt.
pi 1 of t into dt. Okay, S2 of t exists for what interval? Yeah, we need to write the limits, na?
0 to 2, sir.
Yeah, S2 of t exists over interval 0 to 2, but pi 1 of t exists over only 0 to 1, right?
Yes, sir.
Yeah, so because of that means from 1 to 2 the value of pi 1 of t is 0. So can I write directly integral 0 to 1, right? Then the value of S2 of t is 2, right? And the value of pi 1 of t, what we got? It is 1, right? Yes or no? dt, is that enough? Hope it is understood. See, S2 of t actually exists up to 0 to 2, but the value of pi 1 of t exists only up to 0 to 1. So that is why I wrote the limits from 0 to 1. Okay. So from 1 to 2, the value of pi 1 of t is 0. So I am leaving that part, right? So with this, what I can say, the value of S21 is equal to 2, right? Over an interval 0 to 1. Okay, and it will be 0 elsewhere. Yeah, now S21 pi 1 of t, right? So S21 pi 1 of t, S21 value is 2, right? And pi 1 of t value is 1 over the interval 0 to 1. So that is why I can write S21 pi 1 of t will be equal to what I can write? 2 over the interval 0 to 1. And it will be 0 elsewhere. Okay, so we could find out what is S21 pi 1 of t. Then we know what is S2 of t, right? So then we can find out what is G2 of t. Yes, quickly, any one of you can say how do we find? So let me draw here. This is my S2 of t. I said S2 of t exists over the interval 0 to 2. 0 to 2 with a magnitude of 2, right? Then I have understood, or we found this S21 pi 1 of t, right? Its value is again 2 over the interval 0 to 1, right? Till this 0 to 1, its magnitude is 2. Hope it is clear, right? So we need to subtract now. So this portion is overlapping, right? Right. So S2 of t minus S21 pi 1 of t. So that will give you the value of G2 of t. So G2 of t. Let me change color. So yes, what I get, any one of you can say till 0 to 1, right? It is overlapping, right? So 2 minus 2, it is 0, right? From 1 to 2, 1 to 2, what I get? Here it is 2 and here it is 0, right? So 2 minus 0, it will be 2. So I get a square pulse between 1 to 2 with a magnitude of 2. Is this clear? Yes, is this fine? I'm asking.
Yes, sir.
Yeah. If I scroll up, is it fine? So what we can write is G2 of t will be equal to what I can write? It will be 2, right, over the interval 1 to 2. Okay, when t greater than 1 and less than 2, its value is 2, right? And it will be 0 elsewhere. So after finding G2 of t, what is the next step? Yes, Sobik Roy, can you say what is the next step after finding the G2 of t? Sobik Roy is there? Sobik Roy? No.
Yes, sir.
Yeah. After finding G2 of t, what I need to do? Yes, so hope if I scroll up, is it fine? People have noted? Yes, I'm asking you people only. Have you noted? If I scroll up, is it fine? I'm asking.
Yes, sir.
Yeah, Sovik.
Yes, sir.
Yeah, I found the value of G2 of t. Then next, what I'm supposed to do? Yes, what we need to do, man, after finding the value of G2 of t, we need to find its energy, no? Yes or no?
Yes, sir.
Yeah, can you tell what is the formula I can write for energy of the signal G2 of t? Yes, formula. What, man? Still you people can't. say what is the energy of a signal. See, if I want to find the energy of a signal g2 of t, it will be what? Integral 0 to t g2 square of t into dt. So which is equal to what I can write? Integral. Okay, here the limits is okay. So limits is what? It is from 1 to 2 because g2 of t exists over the interval 1 to 2, right? And the value of g2 of t is 2 over this interval. So it is 2 square into dt. So this is nothing but what? At least this simplification. Can you tell, man? Sovik.
Sir, 4t power 1 to 2.
What, man? 2 square is 4. Then
4t.
if I substitute the limits, is 2 minus 1. It is 1, no? So it is 4
Yes.
only, right? Can I
Yes. Sir.
write it? Yeah. So the energy of the signal g2 of t is 4 over the interval 1 to 2. Okay, and it will be 0 elsewhere. Okay, after finding the energy of the signal g2 of t, what is the next step? Yes, who can respond?
Sir, phi 2 of t.
Yeah, we need to find pi 2 of t. See, pi 2 of t will be equal to what? g2 of t, right? Square root of energy of the signal is e2, right? And I know what is g2 of t. What is g2 of t? It is 2 over the interval 1 to 2, right? So 2 divided by square root of EZ2. EZ2 is 4, right? So 2 by square root of 4, which is equal to what? It is nothing but 2 by 2, which is equal to 1. Okay. So I can say pi 2 of t will be equal to 1 over what interval? When t is less than or equal to 2 and greater than 1. That is between 1 to 2, value of pi 2 of t is 1 and it will be 0 elsewhere. Okay. So we find what is the value of pi 2 of t. Yeah, then we can draw the diagram also, and in the meantime I can say what is S22 also. Okay, S22 will be G2 of t, okay, divided by pi 2 of t. This is a formula for finding the value of S22. So which is equal to what? G2 of t divided by pi 2 of t. So G2 of t value is 2 and the value of pi 2 of t is 1. So 2 by 1 will be equal to 2. So the value of S22 is 2. You can write the interval. For what interval? It is between 1 to 2, right? And it will be 0 elsewhere. Okay. So let us draw the diagram also for this pi 2 of t. So let me draw it here, right? So pi 2 of t will be equal to what? It is 1 for what interval? 1 to 2, right? I get a square pulse in 1 to 2. Okay, this is my pi 2 of t. Yes, hope I completed this step 2. I think, yeah. Yeah, let me draw here pi 1 of t also. I think I have not drawn. Have I drawn? Here only let me draw graphically. So this is the time, right? and this is phi1 of t. So its value is 1 for the interval 0 to 1. Okay, fine. So we could find out what is phi1 of t, what is phi2 of t. Yes, then any one of you can say what is the next step. Yes, quickly.
G3 of t, sir.
Yeah, we need to find out the value of G3 of t, right? So that is our next step. Yes, hope people have noted. If I scroll up, is it fine? Yeah, in step 3 is what we need to find out the value of G3 of t. So what is G3 of t, which is equal to S3 of t. Yes, Ananta, can you say? Ananta is there? Ananta. So no Ananta. Yes, whoever is willing to answer this, you can answer. G3 of t. What can I write?
S3 of t minus S31, phi1 of t minus S32, phi2 of t.
Yeah, S3 of t minus S31 phi1 of t, right? Minus S32 phi2 of t, right? Okay. So we need to find out S31, then S31 phi1 of t, their product, then S32, then S32 into phi2 of t. Then we can subtract from S3 of t, then I will be able to get G3 of t, right? Yeah. Yes, Susan, can you tell how do I find the value of S31? Susan is there? Susan?
Yes, sir.
No, Susan. Yeah, Susan, can you tell me? How do I find the value of S31? S31, man, what is the formula?
Sir, integral of 0 to t.
Yeah, integral 0 to t. Yes.
S3 of t into phi1 of t.
Yeah, S3 of
dt.
t into pi1 of t into dt, right? Okay, so with this, S3 of t exists for what interval? So S3 of t exists from 1 to 3, right? But pi1 of t exists over interval 0 to 1. So what is the limit I can take here? Can I take it is from 0 to 3, right? Is this fine? S3 of t, okay, pi1 of t into dt. Just I wrote the limits. Now let me expand that. So I can write 0 to 1, right? The value of S3 of t is 0. Yes or no? But the value of pi1 of t is, it is 1. Anyhow, it is 0 into 1 is 0 only. Okay, then again from 1 to 3, right? 1 to 3, the value of S3 of t is 1. Yes or no? But the value of pi1 of t is 0. So totally I will be getting what? 0. Yes or no? So the value of S31 is 0. Then S31 into pi1 of t. So S31 is 0 over the interval. I can say till 0 to 3. So the next S31 pi1 of t is also becomes 0. Because S31 is 0, right? So S31 pi1 of t will also be equal to 0. Fine. So similar to that, so how do I find the value of S32? Chandan is there? Chandan, Bharati. No Chandan, no Bharati. Then who else is there? Yes, those who are not responded so far. Yes, I think I will leave it to you people only. You should respond. Yeah, quickly. Can I know what is the expression for S32? Yes, be fast. Hello.
So integration 0 to t S3 of t phi 2 of t dt.
Yeah, S3 of t, right? Pi 2 of t into dt. So which is equal to what I can write. So integral limits will be what? S3 of t exists over interval 0 to 3, right? So S3 of t pi 2 of t into dt. But let me now split the limits. So S3 of t any of exists from 1 to 3, right? So let me say 0 to 1, 0 to 1. The value of S3 of t is 0 and the value of pi 2 of t is also 0, right? Is it 0? 0 to 1?
Yes, sir, it's 0.
Right, it is 0. So 0 into 0 into dt I can write. Then plus, then 1 to 2. So 1 to 2, the value of S3 of t, it is 1, right? And the value of pi 2 of t is also 1. Is that correct? Yes, from 2 to 3. Right, the value of S3 of t is 1 and the value of pi 2 of t is 0. 0 into dt, right? So out of these three terms, so this term is 0, right? And even this term is also 0. So only the middle term I get. So which is equal to what I can say? Can I say it is 2 or it is 1?
Once.
Yeah, 1, right? So the value of S32 we found it is 1. Over what interval it is? Between 1 to 2. Okay, the limits, writing limits is very important here. So the value of S32 will be equal to 1 over the interval 1 to 2. Okay, and it will be 0 elsewhere. Then S32 into pi 2 of t, right? So S32 into pi 2 of t will become what? Anyhow, S32 is 1 over the interval 1 to 2, and the value of pi 2 of t is also 1 over the interval 1 to 2, right? So with that, I can say S32 pi 2 of t will be equal to 1 over the interval 1 to 2. Okay, 1 to 2, and it is 0 elsewhere. Fine. So now I found S31 pi 1 of t and then S32 pi 2 of t. So now I can find out what is G3 of t, right? So first let me draw. Hope noted, na? So I scrolled up. Yeah. So let me draw here first the S3 of t. So S3 of t is what? Yes, quickly, anyone of you can say the value of S3 of t. Yes, people not responding.
So it ranges from 1 to 3.
Yeah, it ranges from 1 to 3 with a magnitude with an amplitude of 1, right? So this is S3 of t. Then next one is what? S31 pi 1 of t, right? So next signal is S31 pi 1 of t. Yeah, quickly, any one of you can say what is the value of S31 pi 1 of t? S31 pi 1 of
0.
t. Yeah, it is 0, right? It is 0 only, right? Yeah. So even I can say 0. Okay. And then I would have left that. Yeah. Then next one is what? S32 pi 2 of t.
It's 1 between 1 and 2.
Yeah. S32 pi 2 of t, right? So its value is 1 between 1 and 2. So this is 1. So let me say here, somewhere here it is 2. Okay. The magnitude of 1. Is that fine? Okay. So what is the common portion it is covering? So here it is, let me write, this is 2, right? So to say this, so this much portion is common, right? Here. Yeah. Yeah, let me write here what is G3 of T, or shall I write here? Yeah, diagram. Yes, who can say what is the answer G3 of T? 0 to 1, 0 to 1, any of it is 0 only, so it is 0, right? Then between 1 to 2, here it is 1, and here also it is 1, so 1 minus 1 is 0, right? Then from 2 to 3, 2 to 3, so S3 of T is 1, but this is rest all 0, right? So what can I write? 2 to 3?
It's 1.
It is 1. So from 2 to 3, right, the value of G3 of T is 1. So I can say the value of G3 of T will be equal to 1 over an interval 2 to 3. So when T less than or equal to 3 and greater than or equal to 2, its value is 1, otherwise it is 0. Yeah, in the same way, we can find out what is the energy of the signal, that is Eg3, so which is integral. I will write directly, so 2 to 3, okay, then 1 square into dt, so which is equal to what? So 3 minus 2 is 1. So can I say the energy of the signal G3 of T is 1, right, over the interval 2 to 3. Is it okay? And it will be 0 elsewhere. So after finding energy of the signal, then I said we need to find pi 3 of T, right? So pi 3 of T will be equal to what? It is G3 of T, right, divided by square root of the energy of the signal Eg3. Okay. So what is the value of G3 of T? It is 1, right, over the interval 2 to 3. Yeah. So which is equal to the value of G3 of T is 1, right? Then square root of energy of the signal. So energy of the signal G3 is 1, right? So square root of 1. So what I can write, it is 1 by square root of 1. Yes, 1 by square root of 1. What can I write?
1.
Yeah.
1.
Yes, very good. So it will be 1 over the interval 2 to 3, and it will be 0 elsewhere. So even I can draw that. Right, this is my pi 3 of t. Right, so from 2 to 3, its magnitude will be 1. So this is my pi 3 of t. Okay, so I found pi 1, pi 2, and pi 1 of t, pi 2 of t, and pi 3 of t. So do you feel that we need to find pi 4 of t or g4 of t? No, no, because already I said s4 of t depends on s1 of t and s3 of t. So with that, I don't have to find pi 4 of t. Just let me sum up and let me write the expressions in terms of the basis, orthonormal basis functions. That is what I wanted to say is that is s1 of t is equal to what I said. It is s11 pi 1 of t, right? So what is the value of s11?
1.
1 now.
2, sir. 2, sir.
2.
Yeah, yeah, s11 pi 1 of t. So the value of s11 is 2 into pi 1 of t I can write, right? So similarly, s2 of t will be equal to what? s21 pi 1 of t plus s22 pi 2 of t, right? So which is equal to what? s21, what is the value of s21? Yes, what is the value of s21?
2, sir.
Yeah, 2 into pi 1 of t plus what is the value of s22?
2.
Yeah, s22 is also equal to 2. So 2 into pi 2 of t. So what about s3 of t? s3 of t is equal to s31 pi 1 of t plus s32 pi 2 of t plus s33 pi 3 of t, right? So which is equal to, yeah, so what is the value of s31? s31 pi 1 of t is 0, right? Yes or no?
Yes, sir.
Yes.
Then s32, the value of s32
1.
1. So I can just write pi 2 of t. Then what about s33?
Pi 3 of t. 1.
Yeah, that is also 1. So I can just write pi 3 of t. Okay. The last one, that is s4 of t, right? So s4 of t is equal to, so earlier as I said, it is 1 by 2 s1 of t, right, plus s3 of t plus s3 of t. So with this, so half of s1 of t means it will be pi 1 of t, right? Yes or no? Can I write just pi 1 of t? Because 2 will get cancelled. Then s3 of t. So this one is s3 of t. s3 of t is what? Pi 2 of t plus pi 3 of t. Okay. So this is how we express all these orthonormal means energy energy signals in terms of the orthonormal basis functions. Okay, is this fine? This is another one, and this is another one, and this is another one. So I hope you might have got the confidence that you will be able to solve without any hesitation. I think people still should come forward in answering whenever I ask. See, I need not call the names, right? Always I repeat every class. I think you take this as your assignment. Okay, I'm giving very simple one. I will add some more in the GCR, but yeah, you can take this as your homework. Okay, so I'm giving two signals. So this is S1 of t. Okay, another signal S2 of t. S2 of t. Okay, so S1 of t exists over interval 0 to t with a magnitude of a. Okay, and S2 of t exists over interval 0 to t by 2. 0 to t by 2, the magnitude of 2a. Okay, so using Gram-Schmidth orthogonalization procedure, so express this S1 of t and S2 of t in terms of its orthonormal basis functions, and also sketch pi 1 of t and pi 2 of t. I think this has also appeared many times in the exam. So try to solve it and give me the solution. Okay. Okay, so with this, let me stop. Is that fine?
Yes, sir.
Yeah. Let me take the attendance.